Good evening, everybody. So, welcome to Climate Talk 18. Today, our topic is very interesting one. It is clean combustion, cooking, and climate. It's a very, very interesting topic, and we have an expert with us. Welcome, Ravi Deka, who is the founder of Akvotransiro Tech Private Limited. Let me brief a bit before briefing a bit about our today's invited guest. This is let me tell this climate talk is a collaborative initiative by Center for Cloud and Climate Changes, Cotton University, which is represented by Dr. Rahul Mohanto. He is here, and Ava Creation Social Impact Foundation, represented by Arup Kumar Boisyo, and myself, Satyan Mohanto from Satyan Mohanto Connect, and Parthapatim Barua from BD Analytica LLP. So, if it is actually it's quite tough for me to introduce because Robbie is a quite different kind of guy whom I admire. Though he is junior to me, I admire, respect, and so let me very few lines about him. Robbie Deka is an experienced innovator and entrepreneur with over 25 years in industrial and sustainable technologies, which is very, very rare in Assam. He founded his company Akvotransiro Tech, Tech Private Limited, which is a pioneering Indian startup focused on eco-friendly inland water mobility. I think this is a very, very rare one, rare kind of a startup he has started. It is not only in India, maybe across the globe. I think he will be among very few. His work includes the designing affordable shallow water propulsion systems and developing bamboo composite boats, which is very unique one, offering a sustainable alternative for marine transport. So Ravi, in his earlier career, he was among the first to introduce clean burning emulsified fuel technology to steel plants, improving combustion efficiency and reducing emissions. He also created an on-site desulfurization process for heavy fuel oil, significantly cutting down the harmful SOx emissions from industrial stack, and his contribution to the emulsified fuel technology have been featured in major publications like Fortune Manufacturing Today and Money Control. This is very important because in Money Control to get any news or any article published is a very prestigious one for us. To help curb deforestation, so Ravi has developed a lightweight, ultra efficient biomass stove that lowers fuel wood uses and reduce smoke, and benefiting both the environment and communities. His work has earned recognition from the European Innovation Council, UNDP, INBER, and the World Bamboo Organization. So I think he is a hardcore innovator. I think it is our privilege that to have with us Ravi today. So it's a brief. He is like today's presentation. He'll be exploring the multifaceted story of the climate change and impact on our planet. So he'll be in part one. He'll be looking into the climate change through the kaleidoscope of the time. Uh, and in the second part, the human intervention, to how we delve into modern contribution to climate change, and the third part is he'll be delve into the neglected areas, spotlight overlooked solutions from improving the public transport and clean cooking technologies to addressing waste heat and avoiding greenwashing in renewable initiative. This is a very, very important one. I think I'll not take much time. So for our future reference, we'll be recording this entire session. So your platform is over to Ravi. Ravi, please.
Thank you, Satanda. It was a very sort of a flattering to hear from you for the praises for me. I consider myself more of a person who prefers not to be idle and find some solutions to problems. So, as Satanda already defined, the more or less the backdrop of my presentation, which I'll be making. I'll just put a few words before I start because there is a lot of, I'll say, climate change hysteria, uh, partly made by companies who want to create issues, partly by journalists who don't know what they're talking about. So, hence, whether there is climate change, of course, there's climate change. Climate is not a static thing, it's a dynamic thing. It's cyclic, it's dynamic. And as the planet evolves, the planet becomes older, so do changes. So the changes are integral part of our life. So I'll make my little attempt to decode from a historical perspective where we stand today and what are the small things that we can do, rather how to adapt ourselves to the changes. Rather than putting cliche terms like attaining net zero, which nobody actually knows what it means, on big posters, is how we human beings can stop soiling the planet and adapt to the changes. So, with this, I would like to start my presentation. So, my screen is visible.
Yes.
Okay, great. So, even though I started with clean combustion, cooking, and climate, I'll in fact start the other way around. I'll start with climate. So, first is to understand the changes that we are going through today, very visible changes, which maybe were not visible for the last 100 years. So, we have to have a frame of reference, and the frame of reference is time, where we human beings are actually about like a very tiny part of the planet's evolutionary timeline. So, first and foremost, whenever we talk about temperature changes or reduction, so first, I won't be going very heavy on data. That I think anybody who's interested can do their own research. Is first that there are interglacial warming periods, which are around 10,000 years, 10 to 15,000, and we are at the 11,000 years now. So there are ice ages, warming, ice ages, warming. So yes, this is a part which has been a part of recorded science, which we cannot, no amount of sensationalism today. However, what we do, we cannot discount the ice cores and the geological samples that have been proven that this temperature rising and changing is a part of our global, is a planet Earth cycle. Likewise, we are our as we all the earliest religions started worship the sun. So whether it's Surya Namaskar or is the Egyptian god Ra, we worship the sun because without the sun we won't be there at all. So the sun also has its own cycles, the Bray cycle and the Eddie solar cycle, which are also pulse in terms of 2500 years to 1000 years, where the sun heats up, the increase of solar radiation, decrease of solar radiation. That not only affects us, it affects even the planet Pluto. So, along with our interglacial cycles, which we have, which is again dependent on so many other sectors, we are also dependent very much on the sun for the ups and downs of planetary heat. Then, to give an example, so these are the cycles we have had what is called as a 8.2 kiloyear event, which happened around 8,000 years back. And that was one of the massive cooling event in the world, which it was also you can say, which is in the period is in the prehistory, not in some early years, which wiped out half the life only because of flora and fauna on the planet, because of the sudden dip in, it was not an ice age, it was just a sudden dip in the middle of nowhere. And we still don't know why it happened. And it was long before fossil fuels, long before even when man was probably still using only rocks and sticks. But it happened. Then, much closer to prehistory, this is something I would like you to pay attention to, is something called the Ka-22 event, which happened very recently. Ka-22 was one of the reasons for which probably the Harappa and Mohenjo-daro civilization collapsed. Civilizations collapsed, the old Egyptian kingdom collapsed, Harappa, Mohenjo-daro collapsed because of why? Because of drought. Very interestingly, in Mesoamerican civilizations also collapsed because the Amazon was going through drought and by Sahara was and Africa was getting flooded. So there's an interchange. Now the KA22 event, which happened say at around 2000 BC, we are seeing a very similar movement today, which is the floods in the Sahara. So while again journalists are going absolutely yelling the climatistas or the pro-climate radicals saying, look, this is what is happening. It has happened before also. Interesting, there's an interchange. Amazon goes dry, Sahara becomes wet. And Sahara becomes a desert, Amazon becomes wet. There's an Atlantic cycle over there, which is involved. So there's a drought in Amazon today. And this has been a historic, it is not a matter of 50 years, 100 years, or even 500 years. It's thousands of years. Sahara was 12,000 years back when was a lush green savanna. The rock we have in southern Libya, we have got rock drawings of giraffes and elephants. And Sahara became a desert even after the first pyramids were built, because it was only in around 1000 BC when the last big lakes of Sahara started drying up. So when suddenly you see there are floods in Sahara and it says, look what is going on, this is because all of human intervention. No, Sahara had a number of rivers. Sahara had a lush green forest. Sahara was a savanna before it turned into a desert. And at the same time, like the Mayan civilization collapse is also attributed to a drought in the Amazon, which we see today. Again, just long before the usage of fossil fuels. So I'll come to why I'm stressing on this. I'll come to us later on in the presentation. Then, in the year much recent, this is already in our AD 536, we had the great climate cataclysm. Even though here it says that it was due to an Icelandic volcanic eruption, the other theories it was a pre-Krakatoa's earlier eruption. In fact, as per the Indonesian lore, there was a mega eruption by which the island of Sumatra and Java got separated. It collapsed in between because of volcanic eruption. So we are still not very sure it was an Icelandic eruption or a Krakatoa eruption, but because of which the entire year there was no sun. In fact, it was called as the year of no sun, the year of darkness. The moon was almost invisible. Virtually all the crops around the year were wiped out. There was a widespread famine in the world, which led to tremendous amount of climate changes, erratic weather, and which subsequently led to further plagues because the rodents prospered on the death of the people and of the livestock. So then there was another plague that followed. And so this year of darkness, even though it was 1 year, it had an effect subsequently on the human civilization for almost 150 years. So, which was due to a volcanic eruption, which completely threw the planet out of gear. Now, time is a factor by which we should see anything that goes on. We cannot jump into sensationalism on the basis of what is happening today or happened yesterday. Now, the biggest planetary ecological disaster of the most, I will say, the one that Western propaganda and Western world till today loves to use the most is that of the death of the Aral Sea, which was started off with the Soviet Union with the damming of the Sir Darya and the Amur Darya rivers in modern day Kazakhstan and Uzbekistan. So a massive inland water lake was reduced to a brine pool. Kazakhstan is now slightly again putting in more water. Uzbekistan saying we are not interested. So we will be doing prospecting of oil in the Aral basin. We are not very much interested in it because for them, their cotton crop is more important than the fish caught in the Aral Sea. The purely economic perspective. Interestingly, 500 years back, only 500 years back, in an area which was 9 meters under the Aral Sea, people are finding settlements which are called as Kerderi 1 and Kerderi 2 and Aral Asar, which were small, settlements to small towns, which are found in Uzbekistan side of the Aral Sea sand, which archaeologists are finding, which was earlier 9 meters underwater when the Aral Sea was full. And that was only 500 years back. So it means the Aral Sea itself is not an age-old phenomenon. It is probably had been, which got filled up quite recently, within the last 500 years. So within, say, 50 to 70 years, the human beings again reduced it to nothing. And it was not by human intervention that the inland, this freshwater lake was built. But this gives us a perspective of what is looked upon as one of the worst ecological disasters of this century. It was actually, this area didn't even exist, this lake didn't even exist 500 years back. Or it existed in a very small size, much smaller than it is today. Similarly, the other side of the planet, which is when you got the destruction of the Amazon rainforest. So today, people have found that close to 120,000 square kilometers of tropical rainforest in Bolivia was actually inhabited for more than 1,000 years. And again, till around the 15th century. 15th century was a time which again was seeing drought in the Amazon. And the Amazon, most of Amazon is covered with an artificial soil, which has got artificial carbon in it, it's got biochar in it, which the Mesoamericans used to increase the fertilizer. So where we see a lush forest today of several hundred years, 500 years back, there were human settlements. So the planet reclaims their own. People move, there is a drought, people move elsewhere, rains fall again, the planet reclaims. Lakes are formed again, forests grow again. So whenever we take a look at the planetary changes and climate changes, we always have to take the perspective of time. Not that I am in any way trying to justify the reduction of the Aral Sea or the deforestation going on around the world. But then again, to be really objective in the analysis, we cannot ignore the aspect of time and the time frame. Now, the second part is human intervention. So, am I saying no, the planet keeps changing, so we have nothing to do with it? No, the climate changes we human beings have since the Industrial Revolution, managed to do a tremendous amount of damage to the planet. And that is not only due to industrialization. Even commercial farming is no better. Europe is today releasing, thousands of kilotons of methane only from their pig farms and from the cattle farms. Why? Because it's an unnatural way of rearing animals and the concentration that they are doing it. Now, as you can see, crop burning, where people can actually plow back the same it has to make it as a biomass. They prefer just a faster way of burning the crops, which is why, it's unbreathable in Delhi. That's why I'm sitting in Guwahati right now. Factories which have not been putting any filters or anything, or they put on those filters, ESPs, and they switch them off at night. Household fires, they may consider very small, they are major pollutants as well. So we human beings, ever since the Industrial Revolution, we have been finding ways how to dirty the water, dirty the air, and dirty all around the ground. If we look at, I mentioned about the Aral Sea. Aral Sea is on everybody's radar because the Americans, the West, used it as an anti-Soviet propaganda. Another no less damaging ecological disaster was taking place in America with the damming of the Colorado River. But They dammed in America, but the effect is felt in Mexico, in the Gulf of California, between Mexico and Baja California, where they completely destroyed the Colorado River delta and the swamp, along with the ecosystem, along with the salinity of the water. They created a complete artificial desert on a place which was a swamp. The desert created dust storms. Dust storms go and settle on the nearby Rocky Mountains. The Rocky Mountains, because of the dust, the snow melts much faster over there, which created, instead of natural release cycle from the glaciers and the snow, the water came down much faster, and they created a complete ecological disaster in the entire area. But because it was in the US, it is in the US, the Hoover Dam is still standing, the Glens Dam is still standing. But now they are trying to sort of release more water and re-irrigate that area, realizing that this is a complete disaster. And the same sand goes and goes, either flies northwards from the bay and falls on the agricultural land. And it is not only destruction of a habitat for, human habitat or the animal habitat, which has also been destroying the crops up north, and also increasing the salinity of the water, which is making it rendering uninhabitable for most of the fishes and the aquatic fauna which was there earlier. So coming back to the, I would just like to add another words. This is in the West. In India, our unabated damming of the rivers, the Ganges has hardly any water today because of the canals. So why we have given so much emphasis on canals over there? So natural flow and the hydrology of the rivers have been so damaged that we are having floods everywhere. And it's not only the floods, because the alluvial, the bottom of the lakes, bottom of the rivers are completely getting filled up because there is no velocity in the water, which is also affecting the evaporation rates, which is also affecting the cloud formation and the water cycle and the precipitation cycle, which is all a part of the natural climatic cycle, which people will fight saying, no, this is very localized. No. The planet functions as a whole. We just can't say, oh, it is only bad in this area. It is not really affecting somewhere else. Another important point which I would like to bring is water vapor. Now, there have been interestingly studies from the 70s on the effect of cooling towers on the climate. So, cooling towers is one cooling tower of a nuclear power plant can release up to 7 tons of water per day as water vapor into the atmosphere, venting. And yet all the nuclear energy companies were sort of doctoring their studies, saying that no, there is no effect at all. A recent study in France said that entire microclimate of that area has been changed because of the excess humidity all across. So now water vapor is as potent a greenhouse gas as methane. But natural water vapor, which is evaporating from the sea and the rivers from sunlight and radiation, that's a balanced, controlled evaporation. This is not a controlled evaporation. One is we are draining the rivers. The water has to come from somewhere. So the water which is going into, like, people love to show the cooling towers as tax as pollution, because many people don't know this is actually water vapor and not industrial pollution. But the fact is, unabated release of water vapor into the atmosphere changes the humidity level, changes the microclimate. The microclimate affects the macroclimate over there, southern place. Then you are taking water from a flowing water source and venting it into the atmosphere. It means you are also removing the water flow from downstream of what it should be. Already we have unabated damming and canalization. Plus we have this another massive venting of water straight into the atmosphere, completely uncontrolled, which also creates, as we are from living in Assam, we know very well that in Delhi you can sit for at 30 degrees, 35 degrees, even 35 degrees and not put on the fan. Here at anything above 25, we are already all suffering. Why? Because of the humidity. This is an area with high natural humidity, where in areas which are not from natural high humidities, what you create is something you get at heat islands. It's a pocket because the water vapor is not dissipating anywhere. So you have got heat and you're trapping in heat locally. Another massive human contribution to the atmosphere is acid rains. Now, acid rains was earlier known as a phenomenon which, American steel plants, coal plants from Detroit and all around, and falling into Canada. And suddenly, everybody's forgotten acid rains recently. Very interesting. But acid rains are there everywhere. Acid rains are there in India. Acid rains are very much there in India, especially in the North Indian areas. They are very much there in China. And this is all coming from SOx and NOx. Sulfur dioxide mostly, bit of trioxide, and nitrogen oxide. And this is partly vehicular from heavy traffic, not from smaller cars. Catalytic converters are quite efficient in that, but mostly it is the industrial. If you go to the Jharkhand, Chhattisgarh belt, where they have all those thermal power plants burning coal, you can feel the acidity in the air by breathing it. It's not even, you don't even have to be near a stack, near a power plant. The entire place smells sour. The rains which they come over there, forget it. They are completely, you can put litmus paper and see it change color. So acid rains have been altering the ground. Acid rains have been altering the atmosphere. And these are all, as I said, the planet functions as a whole. You just can't say that, okay, yes, there is a decrease of pH, it's a bit acidic, but so what? No. It affects everything. It affects the water cycle. It affects even the sedimentation level in the lakes. It's even the algae level in the lakes. So this is all acid rains have been a massive, another human contribution in dirtying this planet. Then we're coming to deforestation. Sorry about the spelling mistake on top. So deforestation started if we go into the industrial revolution. So industrial revolution, they in England, for example, 90% by this beginning of the last century, the forest cover was all off in England. Why? Primarily to make charcoal. Charcoal for the steel industry, because before coking was discovered, invented the coking process for coal, so they couldn't use natural, rock coal because of sulfur infusion. So they use charcoal. So they just to make steel, cast iron at that point of time, they just chopped off all the forests. So close to 40% of German forest was also gone. And these deforestation took place everywhere. Luckily, when it came down, the steel industry came to India, the coking process was already known. So coal was cooked and before it was being used. But prior to that, industrialization might have changed life for the better, but it also was a whole-scale elimination of forest resources. Another part which I had been working very strongly with is waste heat. The degree of waste heat created, vented heat which is vented into the atmosphere is mind-boggling. Close to 75% of all energy produced in one way or the other in the heat. Yeah.
Sorry, your first slide itself.
Yeah, I'm changing the slide. How come I'm not changed? Should I change? It's coming now. Which is it now? Very sorry. I wish somebody told me earlier. So I'll be happy to share the.
This is you are not in a presentation mode actually.
I am in the presentation mode.
Okay.
I was in the present. Now I've come back to the normal mode. Let me keep it like this, so that it will be, I think, better.
Now you are in the deforestation slide.
Yeah, I am seeing the deforestation.
Yeah.
So I don't know. This is something, an issue which I keep sharing. Another application window. Stop sharing. 1 minute. I'll just try to reshare again. So, are you seeing it? Yeah.
Yep.
Is the screen visible?
We can leave the screen, Ravi sir, but you can put it into presentation mode if you
It
click
was
on
in
it.
a presentation mode, but I'm just trying to again
Okay.
from current slide.
Otherwise,
Okay, now you can see waste heat.
yeah, we
Yeah,
can
we can see
see.
the waste.
Okay, let me try changing the slides.
Sure.
Has it changed?
No, no, it didn't change.
Okay, has the changed slide changed?
No,
Yeah,
no.
wasted.
There is some problem with
This is problem with Google Meet.
this. Is no. This is a problem with. I will just then I will keep it like this, and I'll keep
Yeah,
on.
yeah, that is fine. Yeah, yeah.
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 So sorry about the last line also. So basically, close to 70% of all heat, which energy which we generate, goes off as waste heat. It is irrespective of whether it's a internal combustion engine or whether it's an industry. I have worked in the steel industry for quite some time, and where even after using heat exchanger, the stack temperature was anywhere between 600 to 800 degrees. That's pure wastage of energy. One, this creates tremendous localized heat spots which completely affect the weather, the microclimate. To give you an example, how waste heat in an everyday life, just when you are having in the peak of summer in the evening, for example, you're in the city and you just leave the city and you will find that there is anywhere up to 5 to 7 degrees difference between the countryside and the heat which is trapped inside the cities. Now, in the cities, it's mostly the heat trapped in buildings, that's radiational heat, solar radiation, but also tremendously by automotive emissions and by generators. But in the industrial sector, especially when you have clusters of industries, that entire area is much hotter. So the idea is how now there are technologies like using heat exchangers. Another, what I would suggest, which I was working on, nobody was interested, was to use Stirling engines, which are heat engines, for capturing all the waste heat possible to use it to generate electricity. Because there are waste heat turbines also, but then not many industries have been fitting it to try to gain out maximum amount to reduce the waste heat. Waste heat is a massive, all the air conditions which are working in the cities, waste heat. Generators, waste heat, cars, waste heat, industries, waste heat. So we have been actually heating up patches of the planet all through tremendously. So these are some of the areas where we have been. There's a massive, I mean, as I said, how we human beings have been spoiling things. Now, how to reduce waste heat, for example, how to reduce NOx, how to reduce acid rains. One is that you have got adoption of clean combustion technologies. Clean combustion, yes, there are gas is a much cleaner. When you say, oh, no fossil fuels, no nothing, unfortunately, it's a wishful thinking. We have to depend on fossil fuels or nuclear fuel at the end of the day. We can supplement it a bit with renewable energy, but end of the day, clean fossil fuels. But clean fossil fuels are again much, much more expensive. You can use pure hydrogen. Hydrogen is even more expensive. So for creating green hydrogen sounds very good on paper. When you are a industry and you are thinking of using hydrogen for combustion, you have to completely change everything from the metallurgy of the burners to the furnaces. Because when you combust hydrogen, you are going to create wastewater. What do you do with the wastewater also? You will be spoiling your products. So there are so many, it's, I mean, beyond the scope of my little presentation to talk about pure clean. So what we can do, we can use low NOx burners, which are much more efficient, which create much less nitrous oxides, which are directly responsible for creating acid rains. And nitrous oxides are also, which is actually called as a thermal load. Thermal load is nitrogen is a coolant. So nitrogen, the moment it heats, it doesn't like to dissipate. Unlike steam or unlike air, normal air, when you combust, you reduce the oxygen. You create CO2, but you are also creating nitrogen oxides. That is called as the nitrogen thermal ballast. Nitrogen thermal ballast is the main cause for generating waste heat in a combustion system. So using low NOx burners considerably reduces thermal load. Secondly, unfortunately, in developing countries, most of the people manning furnaces and boilers are not very well educated. In fact, they're not educated at all. So there are some age-old techniques which they keep using, which is like push in more excess air. They believe the more air you put in, the better the combustion. Actually, what they do is they create a positive pressure inside the furnace or the boiler. Positive pressure means you vent out more heat. Rather than the heat going, you end up burning more fuel. You have more pressure and the heat just pushes out of the stack. The ideal is to ideal balance, thermal balance is you have to maintain a neutral pressure. But it is very difficult to convince these people, and especially when they are constantly the most of the boilers are okay, they're still pretty good once you can get. Most of the furnaces are very bad quality. So people want, the owner of the plant wants more production. The furnace is already inefficient by its design. So they end up burning more fuel. They end up creating more waste heat, more NOxes. NOx is not, as I said, it's thermal load, which is a waste heat and also an active ingredient for acid rains and for smog. Smog is also mostly nitrogen sulfur oxides. So we can use also heat exchangers. We can use other equipment like waste heat steam turbines. For waste heat steam turbines, you need a source of water to create into steam to push the steam turbine to generate electricity, or you can use Stirling engines. It's almost a forgotten technology, but it is as efficient as the internal combustion engine, and it can work with the smallest up to 10-degree variation of temperature. You can still run a Stirling engine. So this is something that the industry should really explore, how to mitigate waste heat to maximum possible, or when they can mitigate, how to utilize it efficiently to create more energy which can be used elsewhere. Another area which I have been very dear to my heart is the usage of emulsified fuels. Emulsified fuels are petroleum fuels mixed with water. Microscopic droplets of water which are infused in a very stable emulsion, which in a nutshell, when they get combusted, the water increases by 1700 times. It flashes into steam, explodes the droplet. You have got, which is something called a secondary atomization. It burns much more because the droplets are smaller, it burns better. Then there is some very small amount of partial dissociation of water into hydrogen and oxygen, and you get a much better thermal load transfer, and the heat goes and it gets absorbed. There is less carbon deposits, less NOx also generated because the temperature, I mean, the flame itself, the water vapor takes the work of what is called as a thermal load to transfer. Now, water vapor steam has got a coefficient of thermal transfer which is 2.5 times more than that of air. So better transfer of heat. Problem with emulsified oil is it's quite difficult to use, and lots of people not really understanding the technology, they really spoiled it. But I was quite happy to know that it's a technology that never dies. It always gets new proponents, new people, new want, and emulsified fuels and I mean known by different names, are also used in all the steam turbines which are burning on, which are, sorry, not gas turbines for generating electricity, which are using oil. They are all using water in one way or the other to control the flame combustion, to reduce the emissions, to reduce the waste heat generation. I spent quite a few years working in emulsified fuels, but the mental block was very difficult to overcome in India. So at some point I said, okay, let's I pushed the baton to somebody else. So, but yeah, so it'll come down to cooking and deforestation. So we have talked about the industrial deforestation. So when people actually talk of deforestation for the purpose of plantations, like as you have in Malaysia or in Indonesia for palm trees, essentially you're replacing one set of trees with another. Cooking deforestation is one of the worst kinds of deforestation, which we saw earlier also. Virtually all the hills around Guwahati were barren. And the reason was people, even the small scrub gets cut for firewood. And now this in places like Guwahati, it has been largely mitigated because people have moved over to gas. In many areas around the world, even in India, which now it is fashionable to call it not firewood but fuel wood, is a massive cause for deforestation. And the effect is felt the most in the arid areas where there is, as it is, very low vegetation. People having no other means, whatever grows gets cut down. Anything that just grows up has no time because there are dry areas, vegetation grows slowly. Now, India is one of the largest users. It's supposed to be different. I can't say it is the largest. Some say it's the largest. Some say one of the largest users of firewood, and that is spans entire central India. And these areas already are almost arid, semi-dry, being bereft of any tree cover. The entire ecology of the place is completely destroyed because with no trees, there is no water retention at all. So, which is already a very harsh environment, we human beings have completely destroyed it. Same thing is happening in Africa, in sub-Saharan Africa, where like 90% of the households are using firewood. People are trying to change them to charcoal. But excuse me, charcoal also comes from the same trees. It's not coming from plantation trees. So now this is one of the, if you go to Nepal, you go to areas there are many areas in Arunachal Pradesh, in the hilly areas, where you will find that it is not commercial logging which has destroyed the forests. It is the necessity to cook and to keep the households warm. So they have got no way out over there because our houses, unfortunately, unlike in Europe or in other colder places where they are built with very thick insulation to retain the heat, in Asia, most of the cold places, we have actually very small, thin houses. So whether it is in Northeast India or in Nepal, you will find that the houses have absolutely zero insulation. So not only they're burning tons of firewood just to keep themselves warm, to survive, but most of the heat is actually being vented into the atmosphere along with the smoke. Another issue about this is that smoke which is being generated. So biomass, people have been talking about. So this is, you can see the slides. All biomass is not good fuel as well. Like in between, it has been almost banned by all the pollution control boards in India. Many of the industries, burning boilers especially, were starting to use rice husk. Now, rice husk being burned under pressure in a boiler is actually a far more polluting fuel than the worst petroleum fuel. The entire area used to get filled with, solid silica particles. The smoke is absolutely, acidic. It's acrid all through. And you couldn't go to any industrial estate where somebody was burning one or two, if you had two, three plants burning that rice husk, you couldn't enter there anymore. So just by saying that this is a carbon neutral fuel, but the smoke which is being created, and the same smoke, if you go to Delhi now with all the crop burning around, you feel that same, because of there are a lot of them are rice stems. You can already get by the smoke, you can figure out what is being burning. Now, so biomass combustion in for cooking, even domestic cooking, is a massive, the smoke because of the improper combustion, which is creating a tremendous amount of urban, rural, not urban really, rural and suburban smoke pollution, which is there. There have been many technologies for reducing. You can never really have a smoke free biomass burner, but there are quite a few designs for biomass stoves which are not expensive, which are much better than what you can see in the photograph. Unfortunately, there are two factors which come into biomass stoves, which I have stumbled myself. One is the inertia of the people themselves. People are reluctant to change. People are happy with their soka or whatever they call the stove. And no matter where they see, they'll see 101 reasons because to change their mode. Now, for most biomass stoves, the firewood size has to be smaller. It cannot be big. Now they're too lazy to cut it. They are used to sitting on the floor and cooking. They don't want something taller than that. So they will have 101 excuses why not to change. Plus, there is the cost involved. That is one part. Second part is many of the stoves which have been pushed by different NGOs and different organizations are actually absolutely substandard. There they have their own agendas. Somebody has got a massive, there is one organization in India which took a £2 million grant from British Petroleum and developed a pure rubbish stove that burns pellets at a price of 36,000 in order to reduce smoke and make life easier. Now, who's got 36,000 to buy the stove, which only burns pellets and needs electricity or a battery? So, this entire clean combustion sphere has been extremely politicized. There are too many players with very dubious credentials. And very recently, as you may be all aware, there was another big scandal where an American carbon trading company ended up in, a few people, their promoters and somebody else who got up in the docks because of carbon credit fraud. Because they were not really interested. They were just creating carbon credits out of thin air with stoves that didn't work. But nonetheless, the reality is that if we want to start somewhere, this is one of the easiest places to start to reduce household smoke and to increase the efficiency. So that in Arunachal Pradesh, I'm seeing, that bukharis which they use that consumes 6 to 7 kilograms of firewood per hour, and most of the smoke ends up going. Most of the heat ends up going to smoke, not inside the room. Now it's quite possible to reduce it by half. So just think of all the households which every winter use a bukhari, and if you can reduce their consumption of firewood, you are not only saving them money, you are also saving the equal number of trees. You are allowing the forest to recover because the load today is much less, because in many of the places, where electricity is better, connectivity, people are using electric heaters, but then think of the villages, they don't have electric heaters over there. They are dependent on firewood. So clean combustion in a household environment will not only, save lives in terms of smoke, it will reduce the smoke pollution, the smoke load, which is as bad as the industrial pollution. And probably if you quantify it together, it will be coming very close to it. And then also you are saving the forests in the same, and forests and the scrubs, and you're allowing the natural, the cycle of the forest to recover a bit. So I'm just sharing with biomass stove which I have been working on. It's a patent applied for design. As you can see in the flame, I am using eucalyptus firewood. That's eucalyptus wood behind. It's one of the oiliest, dirtiest burning firewoods that you can get. The black oily smoke comes out of it, and you can see by the color of the smoke, from the looking at the flame, that there is no smoke at all. So I won't go much into the design of what went into the stove, but just I'm showing you this photograph to show that clean combustion, and it has got no electricity, no fans, no nothing. It's working only on updraft principle, updraft and preheating air principle. So waste heat is being utilized. I mean, the heat from the combustion is utilized to increase the temperature of the air to create almost smokeless flame. So this is just like a proof of concept that yes, we can reduce, if we are genuinely interested, we can reduce household smoke to almost zero, and at the same time reduce forest deforestation for cooking purpose tremendously. Another topic which I'd like to just add before finishing is the amount of high degree of greenwashing which we are exposed to in every day in the name of climate and climate change. So there is hundreds of millions of dollars are being utilized, or spent every year to give renewable industry a very clean image. The basic thing is now, because I know I'm working with one project of how to utilize wind turbine blades, because now they are just going into the landfills. So there are 43 million metric tons of non-recyclable wind turbine blade, which will be having by 2050, which the wind industry doesn't want most people to know. Now it's pretty much in the news. What are you going to do with the blades? They are made from very tough fiberglass, and even for landfills, they need to spend around 5,000 euros to dispose of one blade. And they are burning few of them in cement plants. It costs them up close to 18,000 euros per blade. Same thing is with solar. So recycling a solar panel actually is more expensive than making one. So there'll be close to like 200 million scrap panels, and that comes from their apex industry. So why I mentioned this at the end, when we think about green tech and we'll go into renewables, green hydrogen, solar, yes, outwardly it looks very good. But then there are lots of hidden environmental costs in both of which is glossed over, which is greenwashed. So whenever we make any decisions, solar, wind, going for solar, there is the cost of disposal of the batteries also. So if it's a lead acid battery, fine, there's a good recycling industry, but they're not very efficient. So we're going to lithium batteries. Now the lithium batteries do we have any recycling facility in India? No, we don't. So there is a cost, there's a big environmental cost where using even renewable energies is there, because we are looking at the one side of it. There are companies which declare bankruptcy just to abandon their wind farms, because they are contractually obligated to remove everything after 25 years. So they say we are bankrupt, we can't do it. So they are just left to rot. So there were a number of instances in Germany, in US, where wind farms are just being abandoned, in UK as well. So when we talk about climate, just to make a synopsis, climate change, yes, it's a very integral part. The climate change is a part of our planet. So how best, what we can do is, yes, we acknowledge it's there. We also realize we human beings play a significant role in dirtying our planet and completely upsetting natural cycles. But then, instead of creating sensation and slogans and cliche slogans, it is my favorite, attaining net zero, which is impossible, no matter what you do, is that we should first be aware, we should be prepared for the changes. We don't know how the changes will affect us now. But the changes are coming, changes are underway. So we should first be aware that the changes are part of the planetary system. We have to adapt ourselves. We have been taught, unfortunately, by Western science, which we adopted, the change is very linear. The change is not linear. It is not very progressive. It is not linear. It's very abrupt. And climate is also, there's a cycle. If you identify the cycle, we can be prepared for it. Then next is we have to learn to mitigate how to reduce all this unnecessary wastages, which is going on. And for people like, and at least for people like me, what I've been attempting to do, whether it's in an industry working with emulsified fuels, clean combustion systems, balancing furnaces, or designing stoves, is the idea is how to reduce waste heat and pollution at a very micro level, and hope that things will pick up and people will see virtue, that things need to be done. We cannot only have greed or desperation basically making our decisions. So when it comes to simple, folks using firewood, how to tell them that, look, there is a better way of doing this without exploiting them. Like that American company I mentioned, they were exploiting the woes of the poor people very cynically, saying we are helping them and creating credits out of thin air, and they've completely spoiled the reputation of clean cook stoves and carbon trading with that. So there should be intent that yes, these technologies are there. Some people are maybe good in doing innovations and design. Other people are much better in convincing the people that, look, this works. Why don't you give it a try? So it has to be a very concerted effort to effect change, to make us adapt to the world which is coming, the changes that are coming, which is basically, yes, the climate. We human beings are dependent on the sun and on the climate. The entire history of the human civilization, when you say settlement, it is always climate. It's never been wars. War may be won. It's a good place. The invader comes and settles there. But if place is abandoned, 100%, it is only due to climate. And that has been happening. Today, unfortunately, with our population, with our firm boundaries demarcated, we have nowhere to go. We have our own homes. So we have to learn how to adapt to the changes and to have a positive outlook, and how to adapt ourselves, how to use technologies which work, not to fall for sensation, not to fall for sensation, to think, to become aware ourselves. So with that, I'd like to thank you for listening to me. Sananda?
Yeah. Thank you. Thank you very much. This is a very insightful, I think, presentation. So far, we have been, doing. So I think we need to right now learn how to mitigate adaptation. And since the COP29 is going on, I think our today's session is not lesser than any COP29. So thank you for this very,
Yeah,
very
yeah.
insightful one. Yeah, so I think on that note, this forum is open for everybody else. So any questions, any discussions, please carry on. Thank you.
Yeah, Mr. Deka, this is a very basic question. So, how do you define now clean combustion? I mean, how does it differ from our traditional combustion technologies? Just a very,
In a nutshell,
it's a very academic question, really.
no issues, no
Yeah,
issues.
yeah.
Combustion is defined by three parameters. One is the fuel which is used, the thermal output, and the emissions. The lesser the emissions, the cleaner the combustion. Now, there's a load balancing question. One is the one is fixed, is the fuel, what you are using. So there are certain, if you're using a solid fuel, you definitely don't have the level of control which you have by using a liquid or a gas fuel. So clean combustion is determined solely on the basis of what is the, emission load which is being generated. Because if there are more emissions, it means it is not burning cleanly, so there is thermal output is less. The cleaner the combustion, unless it's with a low NOx burner where you are actually keeping the peak combustion to maintaining the peak combustion below 1700 degrees in order to reduce NOx. That's artificial control. Otherwise, a clean combustion, you create maximum heat to and reduce the minimum, and have minimum emissions, which is solid and gas both.
Okay.
Unburnt particles, no unburnt particles, reduction of CO. Assuming it's a hydrocarbon, it has to be a hydrocarbon, it's not pure hydrogen. So minimal reduction of CO, because any presence of CO is already an indicator of unclean combustion. And something like SOx, for example, that you have to process the fuel beforehand. No amount of combustion can reduce sulfur oxides, by itself, unless you dope the fuel beforehand or you modify the fuel beforehand. So what you are looking at is reduction of CO is the first criteria. Reduction of unburnt particles and soot is the second criteria.
Okay. Are there presently some promising clean combustion technologies which is available? Which can be scalable to the domestic use, kind of?
For domestic uses, if you are using for biomass, yes. If you are using already gas fuel, LPG or PNG, then it's already as clean as it comes. You cannot really make it any cleaner.
Thank you.
Ashwini, you can speak if you have any questions.
Yes, sir. Ravi, sir, I have a question on this activated charcoal. It was a nice presentation that what you gave, but wanted to understand nowadays activated charcoal is really lot across the world. So, what are your thoughts? How positive or negative it would be on our globe when lots of bamboo farmers are getting into this activated charcoal? And second question is. What are your exposures on the Karnataka area or whatever projects that you have done? So that I'm from Karnataka, Bangalore. So
Okay.
just want to understand how is your research at Karnataka on
My Karnataka experience is limited only to the steel industry and DRI industry, not to plantation or any kind of biotech. So I don't know if my experience in the steel industry will be of any interest to you.
Okay.
Charcoal, activated charcoal is not really a fuel.
Okay.
Activated charcoal is got hundreds. It's a fantastic thing. It can cure your stomach problem to filter the water, and it is an indispensable product. But again, with bamboo making activated charcoal, why is it activated? Essentially, the surface area to make it. So that's essentially the criteria. Charcoal as a fuel, I have my, reservations about it, because one, to create the charcoal, you have to get rid of the volatiles. Now, volatiles is not only the water. Water is only one of the volatiles that you get rid of. But then again, so I would any day say that you use dried firewood or briquetted, wood mass, biomass, then using charcoal, because essentially you are wasting energy. You're taking energy out of it. And they say, okay, it is a smokeless, charcoal burns smokelessly. But believe me, it is smokeless, but it's an invisible killer is there. Its CO is there. So you burn charcoal inside a closed environment, God be on your side. So it is still, just because the smoke is not visible, it doesn't mean it is smokeless. Number two is I am not very happy. I'm not very happy with the idea that coking, I can understand, of coal for the steel industry to reduce the volatile, especially the sulfur. It is an indispensable part required for the steel. And no matter how red category is the industry, we all stay in houses of steel and we want our house to be steel reinforced. Our cars are made from steel. It's a part and parcel which you require. Charcoal, for example, I feel if the wood itself was burned, dried and packaged, you will still get more energy from it. You're not wasting it into conversion. And that dried wood hardly has any smoke. I mean, most of the smoke initially which you have on combustion is the vapor that comes out of it's vapor and unburned soot which comes out. So that vapor you can take care of if the wood is dry. And drying the wood requires much less energy than conversion of it into charcoal. Whether charcoal is a good fertilizer for biochar, I think there are much more competent people than me to answer to that question. So this entire business of making, I mean, activated charcoal, activated carbon, yes, there is a tremendous amount of requirement for it. But there are many other sources also for making activity. It is purely economics. Whether bamboo is better or somebody I know, I met somebody who's making from tea leaf wastage, they are making activated carbon in Assam. So whether to use bamboo, whether to use any other plant, it all depends on the availability. Bamboo has the advantage of being very fast growing.
Right.
So it's very sustainable, it's fast growing. Whether it, end of the day, is the economics that plays out. Now, for example, those people who are using it from the tea gardens, they are getting for nothing, almost for tea gardens are asking them come and pick up the plants, which they are carbonizing and making. So for them, I think for here it is the economics which will play out. Whether it is makes more sense in a place like Assam where they have got abundance of discarded tea plants, I think bamboo will have a tough combination. In a place like Karnataka where, I mean, there's a lot of huge amount of commercial farming, but this is like areca nut or banana. So for that area, maybe bamboo is better.
Okay.
Because you don't have hardwood to convert. You cannot use a banana stem, you cannot convert it into charcoal or activated carbon. So I think economics will play the final deciding role in what is more appropriate. Not
Okay.
anything else.
Yeah. Thanks so much for your input, Ravi sir. Thank you.
Okay. Any more? Any questions?
Yeah. I just ask one more. Mr. Deka, I mean, for our region, actually, for our place, so what policy measures you think can accelerate this adoption of clean combustion technologies? Finally, it has to come to some policies.
Policy in the sense, when I first started designing my stove, I was living in Goa at that time, and I was purely inspired by, my inspiration was, or rather what prompted me, inspiration is the wrong word, is to seeing how the Bukharis, how much firewood is wasted in the Bukharis. Now, when I made this and I demonstrated it, there were people all the way from Andaman to, because I was showing them that you can burn coconut leaf stems, which is completely a waste product for everybody because it's so smoky and so, I mean, so much moisture. Even the dried coconut leaf is got 30% moisture, to Himachal Pradesh and Kashmir. And I showed them that how pine cones and everything can be burned cleanly. There was a very strong interest. Now I'm just saying it not because, just to give you a frame of reference. So there was an active interest from their alternative energy officials in promoting the technology. Unfortunately, in the same meeting, we had people from Northeast also. Well, they just gave a casual glance. I mean, one is for policy wise, I would say you cannot, a government loves to ban something. Oh, this is not allowed from tomorrow. But then what is the alternative? I feel we should promote, the government should take an active step in promoting clean combustion stoves, for example, or even house heating. It's not necessarily only a stove. Even a house heating Bukhari, we should make it on a policy level that you cannot use this kind of thing anymore. You have to upgrade yourself. And we will give you whatever support. I mean, these stoves are not even that expensive to make. So government, I am saying government should distribute free distribution of stoves. I mean, never works. If you give something for free, people will just toss it in the side. but some amount of firm. I mean, it should go with along with education. It's not just I ban, you ban. This is banned. This is to be used. And no education, and some third class stove is being sold, and this happens so many times in India. I mean, all over the world, not only in India. So we need to take a concerted effort where designs are created, and they should preferably not be created by institutions like Terry. I'm just Terry for not saying for Terry, because yes, Terry created a miserable stove, and there are so
Yeah,
many
I know.
organizations that get lakhs and lakhs of rupees of funding. They create some absolute rubbish. Justifies everybody's a PhD over there. Not that I'm insulting PhDs or demeaning them. I feel this is a thing that should be given out to individual, say, innovators working with institutions. So, when an institution like IIT does the testing, when I wanted to test my stove, Guwahati IIT asked me 40,000 rupees per test. So I asked them, what is your qualification for doing the test, and what protocol you are going to use, and what are the equipment that you are going to use? They had no answers. Now, when I wanted to get an MNRE certificate for my stove, I walked to Delhi IIT 4 times. I mean, nobody had a time to even give me a form. So, on the other side, you find that Terry has got some 2 crore grant to create a stove which absolutely nobody is used. Even they don't know where the prototype is lying. So, there should be a policy to encourage new designs with institutional support. I mean, it shouldn't be that IIT Guwahati is given this or some XYZ organization is given this. No, you design a stove. It never works. Get a call for proposals that this is what we want. Come forward with your proposals, and there will be institutional support in developing it. And if it meets up whatever is our wish list, then the government will help in promoting this as a business venture. It is not a 10 lakh rupees grant, for this, and then everybody wants to mentor. I mean, all the government people, all the startup, all these incubators, they want to mentor without knowing what is going on, without having the slightest inkling about the technology which is behind. And that is a very wrong way. I think innovators, designers, maybe an engineer, it may be a sort of wild card like myself. So he may be a person who's been working in combustion for many years, who's saying, this is our task, this is our wish list, this is what we're giving for primary support. This is the institution that is going to work with you very closely. In my board project, I had 3 mentors that ran away in IIT Guwahati. Today, my project has no mentors, because this is serious work and serious testing is needed. So, which people love to be in their words and say, I'm a mentor, but a real word is there. So, there should be a very thick, proper demarcation. That this is the task. These people have given a proposal. This is the primary support will be given. This institution is entrusted to see that proper scientific testing evaluation is being done. Once, yes, it meets our thing, government will promote that commercially. Because most innovators are third-class businessmen, myself included.
Yeah.
So, government support. Now, when Himachal government and Andaman government told me, give us your stuff via EPEDA, which is an Assam government. So I approached EPEDA. EPEDA says we have no staff to do your project. So we are too busy with solar. We don't have. I mean, this is a made in Assam product by an Assamese chap. Interest people in Andaman interest, people in Himachal interest, people in Kashmir are interested. So I said, fine, forget MNRE, forget everybody else. Do it via EPEDA. It's a government to government thing. We will push it through, because it is so good. But our own people saying, oh, no staff, no funds, no this, no nothing. So what we need, as you say, policy, yes, the policy should be multifaceted. One is call for innovations with a strict, this is what we are looking for. This is the institution which is going to be our partner. This is whatever funding support that you're going to get, and it will be stage-wise. We tick mark the stages, let not one person get it. Let 4 or 5 teams work on it. Let it be one person, let it be a team. Then we can actually make a change. I had one eatery in Barpeta Road, who was given one of my prototypes. And I came in saying, I want to buy it. Can you tell me what is the advantages and disadvantages? He taught me so many things about my own store, which I didn't know. About how he is saving money, how is this, what is the drawback, what is this, and how he's been using it on for almost 4 months.
Okay.
So there are people who are proactive. There are people who are saying, it's working, so let it remain. Why do experiment with something else? But yes, there should be a firm policy in place. We have no policy, we have no bureaucratic support, we have got complete apathy.
Yeah, on a different note, I mean, are there ways to integrate, I mean, these clean combustion technologies into our existing energy systems without, I mean, making any significant economic, what you say, disruptions?
In what sector?
I mean, yes, I mean, in any sector that's existing, I mean, we have talked about a lot about waste heat also.
Okay.
Right? So,
There are ways of integrating it into the tea sector, for example.
yeah, let's say,
Now, in the tea sector, there are two technologies, relatively clean combustion technologies from dirty fuel. One is on a very basic scale is instead of using lump coal in a stoker or in a boiler, we can use pulverized coal. The moment you use pulverized coal, you have a coal pulverizer and a pulverized coal injection, you already straight away save yourself 30% from losses. Many of the larger, I mean, I gave that proposal almost 20 years back. Now, nobody listened to me. Then I heard few of the mega gardens were starting to, include that. Smaller gardens are still not doing it. They are wasting close to 30% of their coal by using manually stocked boilers. So just using a pulverizer will take care of it. A more sophisticated approach for coal burning plants. Not everybody has gas, and economics of heavy fuel oil or diesel doesn't work in their favor. So they have to use a coal-based fuel. There is something called a coal slurry combustion. It is almost microscopic granules of coal inside water, suspended in water. We don't have the technology in India. I mean, it has been developed. I have been working on it, but then gave it up. Where coal is 30%, it's 30% water and 70% coal, which is pulverized and mixed in a sort of a coal in a water cavitation system. There you have the advantage of using the controls of a liquid flame or liquid fuel and the economy of coal and cleanest emissions for a coal possible in terms of NOx, in terms of SOx. So that is another technology which can be utilized here. And because we have coal, we have very high sulfur coal, and sulfur can be reduced because you add calcium carbonate into that water fuel slurry, our coal water slurry, and that mitigates neutralizes and mitigates the SOx formation tremendously. Makes it a much more cleaner burning fuel.
yeah, thank you.
So, any more questions?
Yeah, I'd just like to pose a question here. So basically, Ravi, what kind of pre-treatment is required for the firewood or biomass that will be used to fire your stove?
Just needs to be dry. That's
Sorry?
it. No pre-treatment. There's just a size limitation. Size should be around, say, 12 to 13 inches, not longer than that.
So that is the
Dry. In fact, if it is not even very dry, once the stove ignites, the core temperature goes up to 800 degrees. So it just flashes off all the moisture. Once the core temperature is achieved, you can just even put in wet. Not wet, I mean non-dry sticks. It just flashes the heat and.
So what is the size that is required?
Lengthwise.
Yeah, length,
12 to 13 inches.
12 to 13 inches.
Yeah. And they can be as thick as 3-4 inches.
And the stove is, how wide is it?
It is the size of a gas cylinder. That is the best.
Okay. Fair
I
enough.
in fact made it look. I mean, made it the same size as a gas cylinder. And
Okay.
the mouth on top is where the flame is coming out. It's around 4 inches.
Okay. Okay. Fair enough. So, like basically, you need to dry the wood first or the biomass, make it into 1 feet or lesser
Yeah.
or slightly bigger than that,
Yes.
1 or 2 inches here and there, and then fire it.
Yeah.
So, is it bottom fired or top fired?
It is top fired. In fact, it's a hybrid system. It is not. It is a both a hybrid direct combustion and a gasifier stove. Because most of the gasifier stoves, they are not very efficient in burning. They say, oh, we're just producing biochar. A stove is not supposed to produce biochar. Stove is supposed to produce only heat and ash.
Okay.
So I can share a few YouTube videos links. You can actually see it both with a fan, without a fan, and how it actually burns. I mean, there's a vortex flame, and the flame turns by itself around without having any fans.
Okay.
So there is, I mean, that entire vortex is created not for to look good. It looks fantastic, but it looks primarily for mixing the pyrolysis gases, the fresh infused air, and with the circle to sort of concentrate the heat in the center.
Okay. Fair enough.
Okay, I think if there is no question, I think we can wind up, right?
So
Yeah, this YouTube we can look for Ravi Deka. Maybe you can find the channels.
I'll share it. I don't know. Ravi Deka is not there on YouTube. I think it's under the
I
Akvotransiro.
think I have that. Or I'll
Yeah.
take it from Ravi and I'll share it in the group.
Yeah. I'll do
Yes.
that.
Okay. Okay. Thank you very much. I think this is a very insightful, discussion.
An excellent
That's
topic.
Yeah, this is an excellent topic, and this is we are rightly discuss on the running of the COP29. So this is, you can say that this is an Assam 29 kind of things on
So
environment.
I'm very certain. I'm just interrupting you all. I mean, sorry about. I mean, that faux pas with the presentation. I'll just change. I'll just share it with you on the group right away.
Sure. Yeah. Please
So
say it.
you
Then
can
I'll
just,
send
you
it to
can
you.
How
just,
can we reach you actually if we want to reach you?
if you want to reach me, I can. If you want to jot down my number, I can just.
Yeah, please.
It is 813
813
052
052
9
9
772.
772. So we'd like to have one of your presentations at my center university.
Okay. So I'll be honored. Do let me know.
And I
So-
think his boat is also very it's a very interesting
We
one.
want to have another session about his
Yeah, exactly. Actually,
Yeah.
in next session, Ravi will be having on your boat. Yeah.
about
Rahul
not
has
only
tried to-
boats, about his. I mean, we'd love to hear from about rivers basically. From his talk on the his talk on rivers will be equally interesting.
Yeah,
Yes,
no,
yes.
I think that will be more interesting.
Yeah.
Both can
So,
together.
so Ravi,
Just about his rivers. Actually, want to hear from you what you think about the rivers. Actually, your views about our rivers.
yes. That will be interesting. Yeah. So, thank you, Ravi. Thank you all.
I think
Rahul,
Ashwini
thank
has
you.
wants to ask.
Thank you. Yeah.
Ravi, sir, that question, as there was a topic of rivers, whenever you have time or whenever there is a session of yours, I would also be interested to know on the water reservations at the farms or at the areas where there is no much of water facility, and how can we have the farmers get that sources with the current availability, something like that. Wherever there is a less sources, how do we cultivate the water sources so that it can be supplied to the plants or whatever?
Okay. You want me to just give you a brief reply now, or you would like to wait for when we have a talk on
No,
both things?
I think when this the reverse session will take, then we'll
Yeah,
get into it.
reverse.
Right?
I'll just tell. I mean, I'll just small nutshell. I think Ashwini can also do her own search. See, there is almost a lost science, which is called as air wells. Air as in atmosphere, and well as in the well where you take water.
Okay.
From all across the world, there were a lot of indigenous technologies where atmospheric water, because even in a dry place like Namibia,
Mm-hmm.
you have enough atmospheric water to actually, which can be condensed and collected. So there's a science of air wells is almost dead, because with the arrival of pumps and electricity and everything, people actually became very wasteful. So earlier, so many of those are fantastic technologies.
Yeah.
That is one. Number two is, if it is a high fog area, for example, as you have in Namibia, the Atacama coast of the South America, the Chile coast, or in Nepal areas where it's not only Nepal, the entire Terai region of the Himalayas, including ourselves in Bhutan foothills, even in winter you have, these are very arid areas. The rivers run completely dry, and yet there is tremendous amount of fog. There's an entire sea of fog in Nagaland, for example. There's a sea of fog, and that fog can be used with a very simple technology of using just nylon mesh for
Okay.
creating to it latches onto the nylon, condensates down and drips down, and you end up filling entire water reservoirs. It's all about the technologies there. Some of the technologies have to be rediscovered or sort of refined a bit, and there are also active technologies like for cloud capturing. I mean, the fog capturing, which can be used. I mean, Karnataka, I mean, it's a big state, so there is a lot of different microclimates over there. But I can assure you that in the Ghat sections are the ones that face maximum water scarcity in winter. There's a huge amount of fog because it falls in the, one part is the rain shadow area. So the other side where you have the rain coming in. So you still have the fog. So fog capturing is probably one of the best ways to get the atmospheric air. You can't always depend on groundwater sources, because groundwaters, again, we have got the pumps, and just like you have the situation in Gujarat, where
True.
an unabated pumping went on, and now the salinity has entered the groundwater reservoirs. So I would suggest you do research on air wells, one, and number two, fogs. Yeah, fog, the net. You just put in fog net.
Okay.
You will get a lot of resources on the internet. They've been quite successful in the Nepal, in the Terai region. In India, I don't know, somehow or the other, similar thing, nobody has taken it up in the Terai foothills. But in Nepal, it's been a very successful project.
All right. Thank you, Ravi sir. Let's see if there is something that you can capture when you're doing the presentation on rivers. Even that will be helpful for me or maybe somebody else. Yeah.
Okay.
Thanks.
Thank you.
Ashwini, this is Atani here. Just want to chip in with a point. I
Yes.
think what you're saying is significant because the farmers face most of the crisis vis-a-vis water.
True.
I agree with that. But at the same time, it has also been my observation that we cultivate a lot of things which are not localized to the region, to that area, which is why most of these water crisis in the farmlands happen. Punjab is a very good example. The stubble burning is a very better example. I mean, a very relevant example of cultivating something which is not locally consumed. It might be produced here but not consumed. They are doing it as a cash crop, mostly for export and for, almost 100% export if I'm not mistaken. And then they don't have time to plow the stubble back into the soil because the soil there is hard without water. They
True.
cannot wait for the water to come, so they burn it and causing further problems. Now that is a problem which is localized to Delhi. We have rice cultivation across India, so mostly in South India and northeast or east of India, right?
Okay.
But we don't have that problem. Why do we not have that problem in Assam? Why do we not have that problem in Bangalore or Chennai? All are rice cultivating states. Primarily because people don't want to burn stubble, don't care to burn stubble. In Assam, there is a lot of culture around this stubble. We harvest the stubble and then we use it for our Sankranti, or for feeding the cows, or for burning at home by creating mud cakes, like biomass again.
Correct.
But no one does mass burning here. Why? Because we wait for the rains to fall, and when the soil loosens up, we cultivate, we do the plowing. So in
True.
Punjab, they don't have rains so early, and rivers don't have enough water to irrigate all these fields. So they burn it, and then they'll go for the next round of cultivation. Now, next round of sowing, basically, which
Harvest.
creates this localized problem. And then, like Ravi mentioned about free distribution not working out enough. In Punjab also, there a center has given free distribution for machines which are supposed to harvest this hay, harvest this stubble, cut this stubble. People have taken these machines, they have not used it. Why? Because these are given to small and marginal farmers who are supposed to do this, and who are the ones who I mean, everyone burns them, but they wanted to, I think, target small and marginal farmer, because they said we don't have enough money to buy fuel.
True.
So basically, what does it boil down to? They don't want to do it. Simple answer is that they don't want to do it.
They want to.
Yeah, they have to be given a kick on the butt to make them do it.
That's the inertia part which I mentioned.
No, inertia can be broken, right? Equal and opposite reaction, there needs to be put a force to the inertia.
True.
You don't have a machine to do it, you don't have the labor is too expensive. Okay, you have been given a machine, now use it. No, we can't use it because we don't have money to buy the fuel. But you have money to cultivate the soil, you have money to sell it to a foreign agency who will export it, then an exporter. So you have money for everything else except this, because you don't face the brunt or the problem created by burning the stubble. Somebody sits in Delhi and he faces it, so they are not bothered. And that is also political. The local government doesn't want to solve this problem.
Right.
Let the center suffer. Let the center and state government somewhere else suffer. People somewhere else suffer who are seen as more rich because they live in cities. So then it is not always a simple climate action problem, climate change problem, but it is also political, I believe. Like Ravi said at the beginning of his presentation.
I think we have. Thank you, Otono. I think we have already crossed the time. Is 1.5 more than 1.5 hours. We can discuss later also. I'm very sorry. We have a time constraint. So thank you very much, everybody. Till Climate Talk 19, and we are expecting Ravi for another one session on rivers. And thank you, Otono. Thank you all. Thank you,
Thank you
Ashwini.
everyone for giving
Thank
me
you
the
very much.
opportunity.
See you. Good night. Thank you.
Right?
Good night.